delay time depending on the distance. This distance is according to the such an angle. Okay. Now, and then if the such an antenna spacing is equal spacing L, the case of the constant delay, same signal arrive first, this one, and then the same signal arrive here and here. It's same like this. The same incoming signal first arrive here and multiply the W sum 3, and then the constant delay time T according to the angle theta 1, and then it's come, and then the multiply 2, W sub 2, and same way the W sub 1. Altogether sum up same, right? Now this delay time is quite depending on the angle of the incoming signal. If the signal comes from the theta 2, like a dotted line, and then the such arrival distance is a little different, then the delay time also different, right? Now the array antenna work the two different digital filters according to the different direction of arrival, but the same antenna weight. For the theta sub 1, we prepared such an antenna weight set to make such a beam, and then, but theta sub 2, and the same weight, but it's make a one null. The case of the desired signal coming from the theta 1 direction, and then we detect the desired signal only. And then the undesired interfering signal coming from theta sub 2, we make a null state, like that. Now it's work as an equivalent digital filter. That's key point. And then such a theory work well, again at the same antenna coefficient, but depending on the direction of arrival, like a signal came from the minus 160, the desired signal coming, and then the undesired signal coming, minus 120. Is the case that the antenna weight is the same, but according to the arrival angle, the desired array antenna work well for the all-pass filter to the desired signal. But its work, notch filter for the undesired interfering signal, like that. The key point, I try to explain the such an array antenna different from the Schrödinger wavelength signal analysis. It's a simple digital filter theory could be easy introduced. That's a new paradigm to do study. And then I also create something new, more practical. You know this antenna, each antenna, 3-element antenna, but it has 3 antenna coefficients, antenna weight. It's like a delay line combined together. And then the coefficient number, 1, 2, 3. 3 times 3, totally 9. That's a freedom of degree. Is a degree of freedom is 9, right? If 3 antenna elements, but which have a 3 tap delay line, work well, almost same performance than the 9-element antenna which has a 1 antenna coefficient each. And then we can make a compact antenna. Because physically, 9-element antenna, we have to prepare one. Like a mobile phone set. It's a very tiny hardware size, right? If we prepare a 9-element antenna, it's too huge, right? But limited space of the smartphone, we just prepare only 3 elements. But we prepared 3 different delay lines, and then a 9 degree of freedom each other. Here is a result. You see that like a 2G mobile phone is a narrowband solution. The 3G is a wideband solution, right? That was array antenna at the base station first to apply. But unfortunately, it's a notch filter. It's a very narrow notch. Because if signal is a wide signal, like a CDMA signal, we cannot remove all of the interfering signal. We can make a wider notch by using such a tapped relay line antenna, because more freedom of the degree. And then this one, I can also explain this one. You know, the only 2-element antenna, but associated 8 taps of the relay line. Could be same performance on the 4-element antenna of the 1 tap degree. Which one you choose in a mobile phone? Maybe this one, because 2 antenna with such a 8-element taps. It's a very compact, easy to implement than the case of the 4-element or 3-element antenna. Like that. That's also patented. I have a patent. That one, all of the mobile phone manufacturers also pay their loyalty to me. Okay. This is also the case. This why I can find this, because the equivalency with such a digital filter. I found it. This is a better solution for the practice. Size of the antenna. We have a restriction. The smaller we should. But the performance should be equivalent. How we can perform using such an extra element antenna, extra tapped relay line, we said, like that. Here is another theory. You know, once again, the arrived signal has a constant delay according to the such a different angle of arrival, right? Once we have estimate such an angle better, and then we immediately calculate how delay tau. Each same signal arrive first here, and then the constant delay tau second later is arrived, and then the 2 tau second after is arrived this antenna, right? The case, you know that only the 3-element antenna we can apply. But we wish to make a much deeper notch or narrower pencil beam. In the case of the more elements we need. But you see that the 2,000 seconds later, once we sample at the 3-element antenna, and then we have 2 sets of the 3 sample. First instance, we sampled by 3-element antenna at the same time. That's 1 set of the 3 sample, spatial sample, okay, not the time sample. And then the 3 tau seconds later, once again, we sample inside. And then the second set of this 3 spatial sample. Altogether, 3 plus 3, 9 sample. 6 sample, sorry. And then the 6 sample is equivalent a sample by 6-element antenna. Do you understand what I say? Okay. Same way, if we try it again 3 times using such a 3-element antenna, a spatial sample plus 3 times sample, and then the totally the 9 sample. That's equivalent for the such a 9-element antenna sample, right? That means instead of the 9-element antenna, we use a 3-element antenna 3 times in time instance, and then the equivalent result we can get. That's better to make a compact antenna, right? Like the mobile phone is one example. And also the implanted device, like a capsule endoscopy, is a much smaller size, capsule size, right? Antenna spacing could be much minimized. Only 2-element antenna, but 2 times, 3 times time sampling altogether. And then the 4 element and the 6 element, 8 element type of the antenna equivalent performance we can perform. That's also the patent technology. Yeah. Again, that there's such a relationship between the digital filter and the array antenna is a quite new paradigm in the research. One of the PhD students wrote such a doctoral thesis. And then I published a journal paper and also published a book, Springer. No, it's John Wiley and Son. Like that, the array antenna, also the kind of the spatial estimation, spatial spectrum estimation type. Yeah, the key point is how delay. If we can estimate the tau, then it's a correspond to which direction signal comes from. It's a one-to-one correspondence. That was estimate the incoming signal angle. I say that the direction of arrival, DOA, could be an easy estimate from the signal, how correlated each antenna element received signal are. Right? That's also the one.